How about some examples? Because RANSAC is actually used quite a bit. So you guys have already seen this one, right? So here's RANSAC for recognition. This again is from David Lowe's work. And what you can see here is there are a whole bunch of matches that were correct. But here's one, for example, that was not correct. So if we were just doing, say, an affine transform, how many matches do you need to do an affine transform? Let's see. 1 for translation, 2 for similarity, 4 for homography. So affine is 3. I think they're doing affine here. I don't think they're doing full perspective. So basically, you keep randomly picking 3 points, find the affine deformation, and when you happen to pick this one, the correct one, all of these points, you can't even see that I'm drawing all these things, but I am. All of those points become inliers. If you happen to pick this point match, and this point match, you would have said that this box kind of landed here maybe. And then you would compute the inliers and it'd be hardly any. And that's why RANSAC works for the recognition. We talked about the fundamental matrix. Okay, so here, these are actually images that I showed you, again I think it comes from Zisserman, of Harris corners detected on 2 different images. All right. And then we do the putative matches, and instead of drawing a cross, which can be really ugly, we did something else that's ugly. And again, I want to thank Frank Dellart, who stole this slide from somebody else, and I stole it from him. So whoever is annoyed out there, go yell at Frank. He didn't put your name on here either. I think it's Andrew Zisserman. The putative matches are drawn on this picture. Okay, and instead of trying to draw them across, I'm just sort of showing this is the belief about how it thinks the points moved. And remember, this is fundamental matrix. I've got one camera, and I've got another camera, and it's a question of how the points will move in the image. Well, they should all move smoothly according to the epipolar constraint. Remember the epipolar constraint? If I've got 2 views, if you knew the calibration, I could tell you the lines along which they have to move. So these would all be moving along these epipolar lines. But what you can see here is that a lot of these things don't seem lined up. So here we have 188 putative matches done, in this particular case through cross correlation. When you run RANSAC, well, now you find a fundamental matrix that has selected out these points, and you see how they all are lined up nicely. And there were 99 inliers. And here are these points, and you see how they're all lined up not so nicely, like not at all, because they're just outliers. Their matches were just noise. So this is a case where 50%, more or less, of the matches were wrong, and yet RANSAC can handle that. Here's an example from robotics. One of the things these days that people do a lot of is use point clouds. Point clouds are recovered from some form of 3D sensing, whether it's stereo or these days a lot of people use Kinect-like sensors. And what you have here is an image from a set of depth points, and you'll notice that the bunch of these objects have been colored as different things. But notice the table is not colored. The table has been removed from the objects. You might have thought the objects were removed from the table. Not really. The table was removed from the objects. How was it done? What's the shape of a table? It's a plane. So if you know your model is a plane, you say, I'm going to pick some points, define a plane, see how many points lie on that plane. If a lot of points lie on the plane, maybe that's a real plane. That's how they found the table. They used RANSAC. Here's another example. This is actually work done by a student of mine. He was doing some work for a robot seeing objects on a table and pushing them around in order to determine how many objects were really there. But the first thing he had to do was to separate the objects from the table. How did he do that? RANSAC, find the table. Here's a video stolen off of YouTube of somebody doing real-time object segmentation off of a plane. And so you can see it runs easily, effectively, and again, they're using RANSAC to define the plane.